Okay. In this session we are going to make application about photoelectric effect. But before I put a summary for the formulas here, let's review them together. Summary: first, experimental condition of emission. Lambda of the electromagnetic radiation should be less than or equal to the lambda node, which is called the threshold wavelengths, or the frequency of the electromagnetic radiation should be greater than or equal than the threshold frequency. Okay. هلا if the radiation is in vacuum, then you have the relation لفريكونسي بتساوي the speed of light in vacuum over lambda in vacuum. Okay. For a medium, if the radiation is moving in a medium, then the frequency بتساوي the speed of light in the medium over the wavelengths of the radiation in the medium. Okay. V is the speed of the radiation in the medium here. طيب رجعنا 3. في عنا الانرجي of a photon بتساوي h nu. Don't forget h is called the Planck's constant. النيو هي الفريكونسي والاي هي الانرجي of one photon. Condition of emission from point of view of energy. The energy of the photon should be greater or equal to the work function of the metal. With W, the work function of the metal is related to the threshold frequency by the formula H nu node. Okay. Also here, H joule times second. I heard this is. The last here, Einstein photoelectric effect relation, say the energy of a photon is equal to W node plus the maximum kinetic energy of the emitted electron. Okay? Well, kinetic energy of the emitted electron is equal half mv squared, where m is the mass of the emitted electron. Will V is the speed of the electron, is the speed of the electron. And you should take care about this V and this V. You have two V. هيدي السبيد of radiation، هيدي السبيد of the electron. يعني this is the radiation consists of photon. This radiation عندها wavelengths وfrequency وعندها speed. Okay. The emitted electrons from the metal here, it has a speed. فإذن you should distinguish between the speed of the radiation and the emitted electron from the metal. Okay, let's start. I'm going to use your book. Let's see problem 6, page 279. He said that show that for any photon of energy E, the product HE is constant and calculate its value. So I want to verify that H is constant and equal to how much? Lambda E, as we said, the energy of a photon is equal H nu. Consider that the medium is air or moving in vacuum. We can write mu equal يعني this implies energy equal hc over lambda. This implies lambda E is equal h times c. As you see, c is the speed of light in vacuum, and which is constant. Well, h is a Planck's constant, which is constant, so you get lambda E equal to constant, okay? Equal to constant, so we prove it. Calculate its value. It is given here in your book to take h equal 6.6 times 10 power minus 34 joule times second, with c equal 3 times 10 power 8 meter per second. So multiply them, you get 6.6 times 10 power minus 34 times 3 times 10 power 8. Okay, 18 times 10 power minus 26. Okay, what is the unit? This is meter, this is joule. So you get here joule times meter. Okay? Time. Let's see number 7. Number 7, 279. It says, why does infrared radiation doesn't cause sunburn as ultraviolet? Okay? ليش الالترافايولت بتعمل حريق للجسم أكثر من الانفراريد؟ اوكي، بشو لازم نفكر؟ بالانرجي. يعني the radiation that has more energy will cause more sunburns, okay, or will cause sunburns. Okay. Type. Let's look at the energy of infrared and the energy of ultraviolet. As you see in the spectrum of light, we said the light has ultraviolet. This is the visible light, and here this is the infrared. These are the arrangement in the increasing lambda. Look here, the energy equal of a photon is equal h nu, والenergy بتساوي hc over lambda. Look here, lambda of infrared is greater than lambda of ultraviolet. يعني this implies the energy of infrared is smaller than the energy of ultraviolet. So, ultraviolet causes the sunburns, causes the sunburns. Okay? The infrared is responsible for heat, for warmth. Okay? Type. Let's see number 8. Number 8, page 279. What do you have? The work function of tungsten. So you have tungsten. The work function of tungsten. 4.5 electron volt. tungsten is used for lighting. يعني the incandescent lamp at your home, this filament is tungsten. Okay, هيدي هي tungsten. Tungsten. What is the importance of tungsten? It affords high amount of heat, okay, without melting. And because it reaches high temperatures above 2500 degrees, it emits light. Okay, يعني the heating of the filament causes light to be emitted, the white light to be emitted. This is because of this it is used in lighting. It says that the work function of tungsten is 4.5 electron volt, and I'm going to write 1 electron volt 1.6 times 10 power minus 19 joule. What should be the maximum wavelengths of an incident radiation capable of producing photoelectric effect? He is saying what should be the maximum wavelengths capable of emitting electrons. يعني using the definition of the threshold wavelengths, you know that the maximum wavelengths is lambda node. Okay, يعني instead of asking to calculate the threshold wavelengths directly, he gives the definition, okay, in order to see whether you know the definition or not. So, as you know from here, I use this formula. W node is equal H nu node, والنيو نود بتساوي C over lambda node, يعني W node equal HC over lambda node. This implies delta lambda equal HC over W node, H 6.6 power minus 34 times C 3 times 10 power 8 over W node 4.5 electron volt times 1.6 times 10 power minus 19. So you get here, okay, 2.75 times 10 power minus 7 meter. Okay, طيب هلا usually lambda node, because it is very small, it is expressed in micrometer or nanometer. So if I want to change it to micrometer, I multiply 10 power 6. So you get here 0.275 micrometer. Okay? Right. Part B. Part B. Do we obtain photoelectric emission if the tungsten is illuminated by ultraviolet radiation of lambda equal to 50 nanometer? If this is tungsten and you send here radiation lambda equal to 50 nanometer, will there be an emission of electrons from the surface of metal? we should think about what? About the condition, which is very simple to have. We have lambda node, we have it. So I should compare it, just compare lambda with lambda node of the metal. Lambda here, lambda node is equal to 0.275 micrometer, which is equal to 75 nanometer. You should either change this to micro or this to nano. As you see, lambda is smaller than lambda node. Yani this implies electrons are emitted with the speed, Okay. Right. Let's see number 10. Number 10. You have page 280. The work function of a metal is a 3 electron volt. So W node is equal to 3 electron volt. Find the maximum wavelengths of light capable of producing photoelectric effect. So maximum wavelengths, this means lambda node. Okay, similar to the previous exercise, you can write HC over lambda node. Yani this implies lambda node HC over W node. 6.6 times 10 power minus 34 times 3 times 10 power 8 over 3 times 1.6 times 10 power minus 19. Okay, 3 cancel with the 3. You get here 6.6 over 1.6 times 1927 10 minus 7, okay, meter. So you get 6.6 divided by 1.6 يطلع 4.125 times 10 power minus 7 meter. Also here change it, you get it 4.125 micrometer or determine the speed of the extracted photoelectrons when the metal is illuminated of ultraviolet radiation of wavelengths هالقد. So this is the metal, okay, it has lambda node هالقد, and you eliminate it with radiation of lambda equals 0.2 micrometer. He wants the speed of the extracted electrons, the speed of the emitted electron. Okay? Look here first. As you see, lambda node is 0.4125. Look here, lambda is 0.2. Note, lambda is smaller than lambda node. يعني this implies the electron is emitted with the speed v. Okay, so the electron is at the surface and it is emitted with maximum speed at the surface here. Okay, so to calculate the speed, I have W node, I have lambda, I want the speed. First, to find the speed, I should find the kinetic energy of the electron. Okay, so I am going to use Einstein's relation. I have W node, I calculate E, and then I get the maximum kinetic energy. Type. So A is equal HC over lambda 6.6 times 10 power minus 34 times 3 times 10 power 8 over lambda, which is 0.2 times 10 power minus 6. You get here 10 minus 7, 2 times 10 power minus 7 بيطلع عنا 2 3.3 9.9 10 power 15 times 10 power minus 19 joule. Okay, this is the energy. W node اللي هي 3 electron volt is 3 times 1.6 times 10 power minus 19. So you get 4.8 times 10 power minus 19 joule. So from Einstein's relation, the energy is equal W node plus maximum kinetic energy, which means maximum kinetic energy minus W node. So gives you 9.9 times 10 power minus 19 minus 4.8 times 10 minus 19. So you get here 1.5 times 10 power minus 19 joule. Okay, I calculated the kinetic energy. Now I can find the speed using this formula. The kinetic energy equal half mv squared. So this implies V equal radical to kinetic energy over m. يعني gives you 2 times 5.1 times 10 power minus 19. The mass of the electron is given at the beginning of the exercises. It is 9.1 times 10 power minus 31. It is equal to 22. You get 1058,715.789 meter per second. Okay. let's see, number 11. Number 11. Done. Number 11 says, 11, page 280, when light of 0.5 micrometer wavelengths illuminates a metal. So you have a metal and this is light. يعني photons, يعني it has lambda, okay? Electrons are ejected with the speed 6 times 10. So the electrons here will be ejected with V. The speed is equal to 6 times 10 power 5 meter per second. Part A, calculate the work function in electron volt, okay? So I want W naught in electron volt. Look here. I can't use this formula, HC على lambda naught. I can't use it. Why? Because I don't have lambda naught, okay? So I should think about another formula. What is another formula that has W naught? Is the Einstein's relation, as you see. If you have E, kinetic energy, you can find W naught. So E is equal W naught plus kinetic energy. So I have lambda, I can find E, يعني W naught is equal E minus kinetic energy equal HC over lambda, يعني 6.6 times 10 power minus 34 times 3 times 10 power 8 over lambda 0.5 times 10 power minus 6 يطلع 39.14 18 then minus 6.14 times 10 power minus 20 joule or 3.96 times 10 power minus 19 joule. Okay? The kinetic energy is equal to half mv square, يعني equal half. The mass of the electron is given 9.1 times 10 power minus 34 times V, 6 times 10 power 5 square gives you 9.1 over 2 times 10 power minus 34 times 36 times 10 power 10. You get here 9.1 times 18 times 10 power minus 24. 163.8 times 10 power minus 24 joule. Okay? So I substitute here. You get here a W naught is equal 3.96 times 10 power minus 19 minus 163.8 times 10 power minus 24, okay, which gives you 21 13 and 3.96 minus 19 minus 163.8 power is 24 equal 3.9958 times 10 power minus 19 joule. So this is W node. The threshold frequency of this metal, this is very simple. He wants W node, he wants the threshold frequency, nu node, and you know that W node is equal H nu node. Yani this implies nu node, W node over H. تساوي 3.958 times 10 power minus 19 over 6.6 times 10 power minus 34, and it gives you 3.958 minus 19 divided by 6.6 minus 34 equal, you get 5.996 times 10 power 14 hertz. Okay, this is the end of the session. Good luck.